Hey guys, welcome back. Today we're going to go ahead and move forward in Chapter 5, Section 1. We are going to be simplifying and verifying expressions using the fundamental trig identities. Now, 3 of these we have already used in the past. These are the 3 that we will continue using, okay? Reciprocal identities. What that means is that you are comfortable with and you're familiar with the reciprocals. The reciprocal of the sine is the cosecant. The reciprocal of the cosine is the secant. The reciprocal of the tangent is the cotangent. So this is something that's going to help us as we move forward. Then we have our Pythagorean identities. Again, we worked with these a little bit in Chapter 4. The sine squared of theta plus the cosine squared of theta equals 1. Again, you are allowed to manipulate these. And what I mean by that is I can take cosine squared of theta and minus it over to the other side. So at that point, I could state that the sine squared of theta equals 1 minus the cosine squared of theta. Okay, so you are allowed to rearrange these. So again, these Pythagorean identities, the other one is the quotients. So knowing that the tangent is equal to the sine over the cosine, since the cotangent is the reciprocal of the tangent, the cotangent is just flipped. So it's the cosine over the sine. So Madison Olson, I hope you're excited because I know this is a lesson you're going to be fired up for. So now we want to jump ahead to day 2. And what they're asking us to do is simplify a trig expression. When they say simplify, the goal here is that you have to use those properties. You can also factor, which is kind of cool. That's what you're going to see today. But you are not done simplifying until you only have one trig function remaining. What that means is your final answer can't have a sine and a cosine, or you can't have a tangent and a secant. You're only allowed one trig function. So we're going to go for it and just look at a few examples. So if I'm looking at the first one, notice this term and this term, they have something in common. They have a sine of x. So just like any time you're factoring, if something is in common between multiple terms, you can divide that out. So I can divide out a sine of x. Sine of x would cancel a sine of x. This term would have cosine squared of x minus sine of x goes into the sine of x one time. So I can go ahead and do that. Well, I'm not done because I still have sine and cosine. So I'm going to go ahead and look at my trig identities, okay? So if I look here, I can't do too much with the sine. I could turn it into 1 over a cosecant. That's not going to help. But I have a cosine squared of x and a 1. So that leads me to this Pythagorean identities. If I minus the 1 over here, okay, here's my identity. Sine squared of theta plus cosine squared of theta equals 1. I am allowed to manipulate this. So notice I have a 1. The 1 is negative. So if I minus it over here, I'd have sine squared of theta plus cosine squared of theta minus 1 equals 0. So notice, here's my sine squared of theta minus 1. I need to take my sine squared of theta and minus it to the other side. So cosine squared of theta minus 1 is equal to a negative sine squared of theta. Okay, so I'll walk you through this again just in case you were like, what just happened? Both of these terms had a sine of x. You can factor out a sine of x. The sine of x canceled the sine of x, leaving me cosine squared of x minus sine. Sine of x cancels a sine of x. When everything cancels, it's a 1. Okay, we are simplifying, meaning our final answer can only have one trig function. We have 2. We have a sine and a cosine, so we're not done. This has a power of 2, and it's a cosine, and it has a 1. We have an identity that says if you take sine squared of theta plus cosine squared of theta, it equals 1. If I minus the 1 over here, I get this to match. So anything other than cosine squared of theta minus 1 needs to go over to the other side. So I am able to say that this cosine squared of theta minus 1 is the same thing as negative sine squared of theta. So I'm going to go ahead and replace cosine squared of x with negative sine squared of x. Here's the deal. I only have sines. So I just have to simplify this and I'm good to go. Positive times a negative is a negative. This is 1 sine of x. This is 2 sines of x. So when I multiply them together, I have negative sine cubed of theta. That is your final answer. Okay, so it's kind of fun. A lot of it is these properties, okay? I'm gonna start using a separate sheet of paper just to make sure that I don't get it so cramped up that you can't understand what's going on, okay? This was kind of a challenging one. Now this one is more of an easy one. I tried to alternate between something that might blow your mind and something that is like, oh, I can do this, okay? Cotangent of x and a sine of x. Now this one I can go ahead and fit right here. Now cotangent, I could put 1 over a tangent, but that's not really gonna help me. So what I wanna do is look at my other option. If I have a cotangent, I could write it as a cosine and a sine. So I'm gonna go there. Cotangent of x can be written as cosine of x over sine of x. It is equivalent, okay? I still have a sine of x. I'm multiplying by a denominator. This cancels this, so all I have is a cosine of x and I'm done. As soon as you have it down to just one trig function, you're good to go. Okay, let's look at the next one. A secant. All right, secant is 1 over a cosine of theta. Now, if I'm looking at this, well, I have the sine of theta. Tangent of theta is sine of theta over cosine of theta. So this is kind of a lot of stuff going on. First thing that I notice here is I'm trying to divide a fraction. You can't divide a fraction. So for now, I'm going to leave my 1 over cosine. We're going to leave that the way it is. I can't keep this. So I need to go ahead, keep the sine of theta the way it is. Change divide to multiply. You flip the bottom fraction upside down. So this becomes cosine of theta over sine of theta. Okay, so again, what happened? Secant is the same as a 1 over a cosine. Sine, I left on the top. Tangent is equivalent to sine over cosine. I left my 1 over cosine the way that it is. You cannot divide fractions, so I kept the top the same. Sine of theta. Change divide to multiply. Reciprocal of the bottom, so cosine over sine. Now here, I'm multiplying by a denominator, so that cancels. So I have 1 over the cosine of theta. In this set of parentheses, all I have left is a cosine of theta. Same thing happens here. Denominator cancels the cosine. All you have left is a 1. So sometimes everything will cancel and you'll end up with a number at the end versus a trig function. Okay, let's look at another one. Ooh, first thing you want to notice, I'm looking at two terms being added together. What do they have in common? They both have a cotangent squared of x. Pull that out. Cotangent squared of x. If I take out the cotangent squared of x here, what I have remaining is the tangent squared of x. Plus, cotangent squared of x divided by cotangent squared of x would be a 1. So that would be step 1. I'm not done because I still have a cotangent and a tangent. I'm looking at a Pythagorean identity here because I have those powers of 2. So tangent squared of x plus 1. Hey, right here. Okay, remember when you are adding, you have that commutative property, meaning you can add in any order. So cotangent squared of x, here we have tangent squared of x plus 1. That is the same thing as 1 plus tangent squared of x. Thank you, commutative property. Because now this matches perfectly and I can see, hey, that's a secant. So I have cotangent squared of x. 1 plus tangent squared of x is equivalent to secant squared of x. I'm not done yet because you can only have one trig function at the end. I still have 2. I have a cotangent and a secant. Well, cotangent, it's squared, so I could write it as cosine squared of x over sine squared of x. You can do that because cotangent is cosine over sine. It's squared, so you have to make sure that you do square both the top and bottom. Secant is the reciprocal of the cosine. Again, it's squared, so it's 1 over cosine squared of x. Check this out. Cross cancel, cross cancel. 1 over sine squared of x. Now, you don't want to leave it like this because this means the reciprocal of the sine squared. Well, we know what the reciprocal is, so we're going to go ahead. The reciprocal of the sine is the cosecant. because this is squared, our final answer is the cosecant squared of x. How many of you guys are having fun? Madison Olson, I can see the smile on your face. I know you love this stuff. Okay, oh no, we still got 3 more. Okay, so 1 more where we're simplifying, and then we're going to talk about what verifying means. Again, if you're simplifying, this is a fraction. Okay, so give yourselves a little bit of room, or if you need a separate sheet of paper. Secant of t. The secant is the reciprocal of the cosine. Okay, the cosecant is the reciprocal of the sine. So I changed a secant of t to 1 over a cosine of t. Then I changed a cosecant of t into 1 over a sine of t. You cannot divide fractions. So what I need to do, you keep the top fraction the same, 1 over a cosine of t. Change divide to multiply. Flip the second one upside down. So it's the sine of t over 1. Top times top, bottom times bottom. Sine of t over the cosine of t. You're not done. The reason why you're not done is because you have 2 trig functions. You have a sine and a cosine. Hey, but guess what? Sine and cosine, sine over cosine is the same as the tangent. So I can simplify this, meaning I only have 1 trig value, by knowing sine of t over cosine of t would be equivalent to the tangent of t. You're done. Okay, now these types of problems, yes, they're fun, but yes, they can get confusing. When they say simplify, you just have to continue to work with the problem until at the end, you only have 1 trig function, like we did here. It was okay that it was negative. It was okay that there were 3 of them, but it was only the sine that we had remaining. This is a cosine. Hey, if everything cancels and you end up with a 1, awesome, okay? Cosecant, it's okay that it's squared. It's okay if it's not. But the main thing is if it's simplified, you are only allowed 1 trig function in the final answer. That's what simplifying means. Okay, now if you are going to verify, verifying is pretty fun as well. You're using the same properties. If you are verifying, you are going to take the more complex side, and you have to work with this using properties to prove that this is equal to the more simpler side. So I want to take the sine of theta over 1 plus cosine of theta plus cosine of theta over sine of theta. Obviously, this is the more complex side. I have to work with this until it equals just the cosecant of theta. Okay. First thing that I notice is that they want me to add fractions. You can't add fractions unless you have a common denominator. When you're finding a common denominator, you're not allowed to get rid of any pieces. So what I have to do is I have to put 1 plus a cosine of theta on this side. Put a sine of theta on this side. So here's what this would look like. My original is sine of theta over 1 plus cosine of theta plus cosine of theta over sine of theta. My common denominator has to have both pieces. And what that means is it needs to have 1 plus a cosine of theta and the sine of theta. So now what you're going to do is look at each fraction individually and say, okay, what is it missing? The first fraction has 1 plus a cosine of theta. What it's missing is the sine of theta. So I need to multiply that not only on the bottom to create the common denominator, but also on the top. Sine of theta times sine of theta is sine squared of theta. Plus, now this fraction has sine of theta. It's missing 1 plus cosine of theta. Now on the top, you're taking 1 term times 2 terms, so you are distributing. So this is cosine of theta plus cosine squared of theta. So what I've done so far is realize, okay, I'm adding fractions. Let me slide this up here for you. Okay, I'm adding fractions. You have to make a common denominator. When you do have a common denominator, that always carries over. So the bottom is 1 plus the cosine of theta over the sine of theta. On the top, you're adding these together. Okay, one thing that I notice, remember adding is commutative. You can add in any order you want. So I can take sine squared of theta plus cosine squared of theta plus cosine of theta. And the reason why I want to do that is let's go ahead and look at those Pythagorean identities. Sine squared of theta plus cosine squared of theta. Right here. Sine squared of theta plus cosine squared of theta. I can replace this with a 1. So I'm going to go ahead and do this. This is 1. So it's 1 plus cosine of theta over 1 plus cosine of theta over sine of theta. At this point, I can hear you already. You're like, cross it off, cross it off. You're right. This cancels this. You have the same thing on top and bottom. That leaves you with 1 on the top, sine of theta on the bottom. 1 over the sine of theta is the same as the cosecant of theta. That's what you were trying to verify. If you look back at our original problem, you had to work with this side using properties until you could prove, okay, again, it's a proof. You had to work with this until you got it to be just the cosecant of theta. We did it. You're a rock star. High five. Give yourself a pat on the back and a big bear hug. Let's do it again. Okay. Again, that one was a tricky one. I want to make sure that I don't just do all the easy ones with you here. I want to make sure that I'm challenging you while we're actually together through YouTube. Some of them are going to be a lot easier, okay? Like this one. Here's an example of just a basic one. You want to take the more complex side. This is more complex because it has 2 trig functions. I need to work with this side using the properties, just the 3 sections of the properties that we've looked at, so the reciprocals, the Pythagorean identities, and the quotient. I need to work with this until it becomes just a secant of x. So again, I'm just going to go ahead and write this out. Cosecant of x times the tangent of x. Now the cosecant, that's the reciprocal of the sine. Okay, so that is a reciprocal identity. Now tangent, I could do a reciprocal identity and put 1 over the cotangent. It's not going to get me anywhere. Okay, I won't be able to cross anything off. So if I look at the quotient identities from your notes, tangent is the sine of x over the cosine of x. Now that actually got me somewhere because I can cross cancel the sines. What I have remaining is 1 over the cosine. Reciprocal identity, 1 over the cosine is the secant of x. Look how quick that one went. We had to work with this side using identities until all we had left was a secant of x. We have that. We verified it. We're good to go. Okay, I hope this was super fun. There is a suggested assignment. If you're like, whoa, I got this, I don't need to practice, sweet. These are here to give you more practice. There is a Zoom meeting where you can come on and face-to-face. I'll say, okay, 27 to 33, which ones do you need help with? We will do them together. Same thing, 39 to 44. So if any of these things are causing you any issues, I am still here for you and I'm going to help you in any way that I can. I hope this was fun for you and I will talk to you soon.